Hey guys, take a look at number 15 in section 4.4 with me. It's not a really hard problem, but it's a strange problem. So let me go ahead and take a look at it with you here. Gives you a function. Yours should be similar to mine, where we have a linear function raised to a fractional exponent. We have x minus 16 to the 7 over 9 power. Now, we know in order to determine intervals of concavity, we're going to have to take the derivative twice. So that's the first thing I did, is just go ahead and start taking the derivative. 7 over 9 comes down in front of the group. That group is raised to the one lower power, so the negative 2/9 power. Of course, the derivative of the inside's 1, so we don't have to worry about that. Then I went ahead and took the second derivative, and the negative 2 over 9 multiplied the 7 over 9, giving me negative 14 over 81 times the group x minus 16 to the negative 11/9 power. Now, whenever I'm trying to simplify that, I can say, well, all right, to find the critical points. The critical points are needed in the first step here because it's asking me to locate any critical points that lead to a maximum or a minimum. So I knew I needed to set both the first and second derivative equal to 0 because that's typically where critical points are. But that's why I started off by saying this is a strange problem. You're not able to get any critical points or potential inflection points by setting the first or second derivative equal to 0. Because when this group gets to a negative exponent, that means that that only variable in the problem goes to the denominator. You can never divide 7 by any number in existence and ever get a 0. So you're not going to get any critical points by setting the first derivative equal to 0, but hopefully you remember you could get critical points when f prime of x does not exist. And that's going to happen at this problem at x equals 16. Please notice 16 was okay in the domain of this problem because it would give you 0 to the 7 over 9 power, which is 0. That's fine. But now, if you plug 16 into the first derivative, it's going to cause that first derivative to not exist. So I say, okay, I do have a critical point at 16 because it causes f prime of x to be undefined. That exact same thing happens in my second derivative. When I try to set the second derivative equal to 0, it's a fraction that cannot equal 0 because it just has a negative 14 in its numerator. So you say you're not going to get any potential inflection points by trying to set it equal to 0, but just like the first derivative test, the second derivative test says you could also get potential inflection points at any value that causes the second derivative to not exist. So for the very same reason, x equals 16 is a potential inflection point, since it causes the second derivative to not exist at 16. Now, I go ahead and I do my second derivative test with the only potential inflection point of 16. Please keep in mind the domain for this original problem is all real numbers. X minus 16 to the 7 over 9 power. Anytime you have odd exponents, you can have positive or negative x values in here. So this is valid from negative infinity to infinity. I break up that domain with a potential inflection point at 16. So my first test interval goes negative infinity to 16. My second one goes from 16 to infinity. I let a 0 represent the first region and a 20 represent the second region. Then I can say, well, okay, I'm testing the sign of my second derivative in each of these regions. So you'll see I just put my simplified second derivative, negative 14 over 81 times the group x minus 16 to the 11 over 9 power. When I try to test that here, I know that my numerator is negative, no matter what value I plug in for x. 81, of course, is positive. The only factor that's going to change sign is this factor. When I plug a 0 into it, it's going to be negative 16 to the 11/9. It's going to be a negative. Well, a negative divided by a negative is a positive. That tells me that my second derivative, when it's positive in that region, my original function is going to be concave up in that region. When I try to plug in a 20 to test the second region, I know that the numerator is still negative, the 81 is still positive, but this factor, you'd have 20 minus 16, that's a positive 4. 4 to the 11 over 9 power, still a positive. So you can see that your numerator is going to be negative, your denominator positive, thus your second derivative is negative in that region, which means your original function is concave down. Now, if we try to answer the questions here, you can see that 16, it's not a maximum or a minimum. Why is it not a maximum or a minimum? Because it's an inflection. It's the point in which your graph changed concavity from concave up to concave down. So anytime your critical point ends up being an inflection point, it's neither a maximum nor a minimum. So I can say, okay, I go back to my problem, and the first question in it is find any critical points that lead to a maximum or minimum. There is none. So I just say, well, their DNE does not exist. And same thing, there are no critical points that are a maximum, DNE. Remember, in this problem, the only critical point ended up being an inflection point. And in that case, it's not a maximum nor a minimum. So at which points did the inflection occur? And do they want us to put the whole, no, it's just X. Sometimes they want the coordinate, sometimes they just want the X value. So in this case, it's just the X value, and that was at X equals 16. Now, if I look and see when is this function concave up and when is this function concave down, pretty quick answer. The function is concave up when the second derivative is positive, so it's concave up from negative infinity to 16. So I'll go in here and say this function is concave up on the interval from negative infinity up to 16. Negative infinity, comma 16 here. We do parentheses. And then we can say this function is concave down from 16 up to positive infinity. And then I can say, okay, this should answer the question successfully. Shouldn't be any problem. I hit check answer. Correct. Okay, guys, hope this helped you out with this 15. It is a strange question, but hopefully you see the idea behind it. In each of these problems, you're always just going to be taking the second derivative, finding the inflection points by saying it's either equal to 0 or, as in this case, where it doesn't exist. This was just a strange problem, but not really a too bad of one once you get used to it. Okay, hope that helped you out. Please let me know if you have any other questions.